Number 1 says E divided by 2 is less than 3. If E is being divided by 2, the opposite of division is, so I multiply both sides by 2. When I multiply by 2, these 2's would cancel out, leaving me E is less than 6. Okay? Others that I need to work out?
No, but 7. I mean, not 7, 8.
8 says 2 is greater than or equal to 5 plus P. To get P by itself, I have to get rid of this 5. What would I do to get rid of it?
You have to subtract it.
I have to subtract it. It's going to give me a negative 3 is greater than or equal to P. Because it can be equal, it's going to be a filled-in circle, and it says the P is getting smaller, so the line would be a filled-in circle on the negative 3 going to the left. Others from the first 8.
7.
Number 7. 2 is greater than or equal to S minus 2. Again, if I want to get S by itself, I've got to get rid of this subtraction. The opposite of subtracting is? The opposite of subtracting is addition. 2 plus 2 is 4. So I'd have S is less than or equal to 4, or 4 is greater than or equal to S. But you should have what? Added it. Others that I need to work out from that first 8. There is 9 through 14. And again, I'm less worried about 13 and 14, more concerned about can you solve the inequalities. Do I need to go over any of these? Number 10. Okay. Good. Number 10 said 9 is greater than a negative r. It's really important to understand that when a variable has nothing in front of it, that there's either a 1 or a negative 1 that's implied. This says a negative 1 times r. How do I get rid of multiplication? Division. I'm going to divide by a negative 1. The minute I divide by a negative number, what do I have to do with my inequality? I have to flip it. This is going to be a negative 9 is less than a positive r. It would be an open circle. If I was graphing it, it'd be an open circle on negative 9. And it says r is getting larger, so it would be going to the right. I want to get the variable by itself. To get rid of this negative 2, I would add 2 to both sides. B is less than 5. Any others? Listen, at the beginning of every lesson, at the end of every lesson, and at the end of every assignment, you should be self-rating yourself by that rubric that we've been talking about as far as where you're at with your understanding. Are you at a 0? Even with help, you really can't do any of it. Are you at a 1? With some help, you can do a little bit of it, but you have not a lot of understanding. Are you at a 2? You can do a little bit on your own, but on some of the more difficult ones, you've got to have some help. Or are you at a 3, where you can do all the pieces and get the right answers? Are you at a 4, gone beyond something maybe that's even been taught in the classroom? Today, we're talking about solving two-step inequalities. Do you think there's going to be a lot different today than what we did yesterday? Not a lot different, right? Instead of one-step inequalities, we're going to do what? Two-step inequalities. What's the only thing that we learned about inequalities yesterday that was significantly different than an equality? Yeah, and when you divide by a, you have to flip that inequality symbol. That's really the only thing that we did different. Now, I'm going to tell you, you can find these two problems on the top of page 218, but there simply is not room to work them out. And on the top of page 218, the directions say use algebra tiles, and we're not going to use algebra tiles to represent this. We are going to solve them and graph them. So you're going to want a sheet of paper to write these two examples down. You might be able to squeeze it in on the sidelines.
Are you recording the class?
Mm-hmm. I didn't do it. Hmm? That was 5th period. No, it just records what it can see and what it can hear on the screen. Mm-hmm. It's recording. It won't hear you very well. I moved my microphone from up in front to over here because my knee was bothering me today. So I sat down. So my microphone's sitting on my desk. It's going to adjust the volume to my voice. That's what it's going to do. And so it won't pick up a question in the back of the room very well unless it's what?
Wow.
That it would have picked up, right? Okay. Let's go and talk about how to actually solve this problem then. Remember that the whole goal is to get what by itself?
The variable.
I want to get the variable by itself. Please make sure you're writing the examples down. If I want to get this variable by itself, the first thing I have to undo is this addition. I'm going to subtract 7 from both sides. Please stop with the background noises. Just swap it out. Just take one of mine and put that one in there. I'll sharpen it some other time. This is going to leave the 2x. These are going to have crossed out. And 11 take away 7 would be 4. I didn't have to flip or change my inequality symbol because I didn't multiply or divide by a negative. X is still being multiplied by 2. What's the opposite of multiplying? Divide. So I'm going to divide both sides by 2, leaving me x is greater than, 2. If I had to graph that, would I want an open circle or a closed circle on 2? It would be open because it can't be equal to it. And would I be going to the right or to the left? It says x is on the bigger side, so I've got to go to the right where the numbers are getting bigger. Everybody have the first example? When I go to do the second one, remember the same goal is in mind. I want to get what by itself? The variable. I've got to get rid of the subtraction. I've got to undo it. How do I undo it? I'm going to add 4 to both sides. It's going to leave me 5h greater than or equal to 15. Again, I'm going to ask that you're writing all the examples down. H is still being multiplied by 5. What's the opposite of multiplication? So I divide both of these by 5. These 5s would cancel out, leaving me just h is greater than or equal to, and 5 goes into 15 3 times. Again, if I were looking at a graph, would I want an open or a closed circle on the 3? Closed, because it can be equal to it. It says h is getting bigger than 3, so which way do I want to go? I want to go to the right. Any questions on the first 2 examples? Okay, you're going to find these on page 220. And again, there may not be room to work these out there. And I want to talk about the style of this question. It says, circle any given values that will make the inequality true. This is real likely to be a style of question that you'd find on your FSA this year, where it says circle all that apply. And they might have 10 or 15 numbers that are there. In an inequality, how many solutions really are there?
One.
Infinite. Anything that's on the side of the line that is shaded would make the inequality true. So there's lots of correct answers. There's one correct answer as far as the way you get the inequality. But if you pick numbers that would make a true statement, there would be an infinite amount of them that would solve it. So, when you're given a question like this, you could substitute these 3 values in, but you would have to substitute them all in. And it's easier just to solve it to see which ones would be true or false. So I'm going to take that equation where I can work with it, and I'm going to solve it, just like I'd solve any other ones. I want to get this variable by itself, so the first thing I'm going to undo is the subtraction. How do I undo subtraction? I add. I now have 3v is greater than 30. What would I do now? Okay. I'm going to divide both sides by 3. I'm going to get v is greater than 10. There's 3 possible answers to choose from up here. It could be none of them. It could be all of them. How many of them am I going to circle? 1. Which one? I disagree. The only number that is greater than 10 is which one? 11. It can't be equal to, so I didn't circle it. And it certainly can't be less, so I didn't circle it either. Okay? Number 5, same type of question. 5h plus 12 is less than or equal to -3. If I'm getting the variable by itself, what am I going to do first? What am I going to do first? I'm going to subtract 12.
Oh, wow.
Please be careful over here.
Yeah, I get messed up on that.
What's a negative 3 and a negative 12 when I put them together? Negative 15. They both have the same sign. I add them together. I'd now divide both sides by 5. It says h is less than or equal to negative 3. Now, I need any of these that would make this a true statement. Which ones are less than or equal to a negative 3? Negative 3 is negative 4 less than a negative 3?
No.
It's not?
Yes.
All three of these, this time, would make a true statement. Negative 4 is certainly less than a negative 3. Negative 5 is also less than what? Negative 3. Negative 3 is equal to a negative 3. So all three of them would have worked this time. Well, here we go. Let me graph this real quick. If I took the time to graph it, it'd be a filled-in circle on the negative 3, and it'd be all the numbers that are less than that. So, if I'm looking at the graph, was negative 3 colored in? Yes, it was filled in. Was negative 4 where the line was? Yes, it was. Was negative 5 where the line was? Yes. All of those would satisfy it. Numbers that wouldn't satisfy it would be like a negative 2, negative 1, 0, 1, 2, and so on. Okay? Are we good?